Thank you for choosing Dykewall, and welcome to our podcasts. Before we start, please don't forget to like, subscribe, comment, and share. It is really important to us. Hit that notification button as well, because there is more to come. You can get more detail about Dykewall and our courses on our website at www.mydykewall.com. We hope that you enjoy this one.
This section is Security Practitioner 210, Hostile Vehicle Mitigation. And this section is called Designing HVM Measures.
Risk assessments. Every operational requirement needs a reason to exist. The determination of the reason to exist must be made in a systematic way and documented, so that it can be used to develop appropriate measures. The starting point to determine if or why there is a requirement is a risk assessment. A security risk assessment will identify and quantify the threats and the vulnerabilities that a person, facility, or operation may have. It will consider the impact to the person, facility, or operation, should the threat materialize. A risk assessment is bespoke to the people, facility, or operations concerned. Standard operating procedures. Standard operating procedures are the documented instructions on how to carry out a task, or an assignment, for any given situation. The SOPs will be derived from the mitigation measures that come about as a result of the risk assessment. Every security operation should have an SOP. An SOP should explain what the procedure is for, who it applies to, who is responsible for it, and an actual step-by-step guide to carrying out the task or assignment concerned. An SOP often contains a flowchart to indicate the variables that could change the direction of the instructions, such as an escalation procedure if something goes wrong. An SOP is bespoke to the people, facility, or operation concerned. In the case of hostile vehicle mitigation, a set of SOPs will be required to describe the procedures for allowing authorized entry to the controlled zone, and also, what to do if there is an impact on the HVM line. Impact assessment. This is not an assessment of a vehicle impacting an HVM line. An impact assessment is a process that evaluates the economic, social and environmental changes that could occur if something happens. For example, if an HVM is put in place, an impact assessment would consider how that changes the normal operations, and whether there would be any negative, or positive, impact. An impact assessment is necessary to ensure that security measures are not going to inhibit operations, discriminate against anybody, or have a knock-on effect to other operations. Design considerations. A threat, vulnerability, and risk assessment should identify the need for hostile vehicle mitigation measures to be put in place. However, a specific HVM risk assessment and impact assessment should identify what type, or what rating of HVM, is required. Hostile vehicle mitigation can be anything from chicanes and landscaping, to a bespoke device that can stop a 7,500 kg truck, hitting it at 80 km per hour.
At this point in the module, is a link that takes you to a video of a truck hitting an HVM device, as it is tested. The image in the text is credited to an HVM company called Frontier Pits. It shows the point of impact when a rising blocker stopped a 7,500 kg truck at 80 km per hour.
The starting point for an HVM design is dependent on the scenario. If a new district is in master planning stage, then there is much that can be done to reduce security risks before construction starts. By carefully planning the location of different types of facility, and the road infrastructure that supports them, it is possible to avoid direct fast approaches that could allow a vehicle to gain momentum prior to impact at the asset. At master planning stage, it is also possible to introduce the concept of landscaping to control traffic, and pedestrianized dedicated areas, to provide a layered approach to security. Introducing CPTED into a design as early as possible will reap many benefits, from increased security to a better integrated environment, and it will save money, compared to building security on top of a design. CPTED stands for Crime Prevention Through Environmental Design, which is a multidisciplinary approach to crime prevention, through adjusting the built environment at design stage. It seeks to reduce public space crime by changing designs, so that criminal acts are either deterred, or made too difficult to be successful. The 4 principles of CPTED are: natural surveillance, natural access control, territorial reinforcement, maintenance and management. However, even though best practice is to design security in, rather than on a development, we often find ourselves designing HVM schemes into an existing environment. This may be because threats change over time, and when many areas and buildings were built, the threat of a hostile vehicle was a lot lower. The starting point for an HVM design in an existing environment is to understand the threats and the risks through TVRA, and cross-reference those with a vehicle dynamics assessment. A vehicle dynamics assessment studies the vulnerabilities associated with each vehicle approach route, and will define what levels of HVM will be required to mitigate the risks. A VDA should assess the following as a minimum: potential vehicle types that could approach, available approach routes, angle of approach, potential speeds of approach, road surfaces and inclines. The output of the VDA is a documented record of the calculated vehicle mass, and impact speed, and the perceived point of penetration. The worst-case scenario, and biggest risk in terms of hostile vehicle mitigation, is a long straight road with a good surface, and a downward incline that heads directly towards the asset, with a 90-degree impact angle. In this scenario, a large vehicle could gain a lot of speed and deliver its payload with significant force. The following diagram simplifies the vehicle dynamics to head on at 90 degrees to the target, an approach that hits the target at less of an angle, and to one of a parallel approach.
At this point in the module is a diagram that shows how a vehicle can approach a building either straight to, at an angle, or run in parallel to it.
As the angle of impact changes from perpendicular to parallel, the amount of potential energy transmitted to the building decreases. If we now consider the same 3 scenarios, but with HVM bollards installed, you will see that the angle of approach has an even greater part to play in protecting the asset.
There is a second diagram at this point, that shows the same as the first, but this time with a row of HVM measures about 20 meters from the building. This distance is labeled as standoff.
The green line in the diagram represents an HVM measure, for example a row of bollards. The perpendicular approach is likely to hit 1 or 2 bollards only, and all of the force will be dissipated through these to stop the vehicle. Whereas the angled approach is likely to hit more of the HVM line and therefore dissipate the energy across a wider area, which in turn is likely to provide a better, stronger defense than the perpendicular approach. The parallel approach does not hit any of the bollards, and if the vehicle tries, it is likely to be bounced off and continue in the direction that it is traveling. There are many forms of hostile vehicle mitigation measures, and these will be discussed later in this module. However, there are some basic considerations needed when choosing the right method for any particular scenario. The first is whether authorized vehicles are allowed through the HVM line. If they are, then an active section will be required that can be lowered, or opened, to allow the authorized vehicle to pass. The opposite of active is passive, and this term is applied to any HVM measure that is fixed, and will not allow a vehicle through. The second consideration is whether pedestrians are allowed through the HVM. If so, the scheme must not discriminate or interfere with people passing through. Studies have found that a 1,200 mm air gap between measures has very little impact on people flow. Similar studies have shown that the same gap has very little impact on a blind person with a white cane. However, two people in wheelchairs would have to pass in single file, so to avoid discrimination it might be worth considering having narrow measures in some areas, so that two wheelchairs can pass side by side, one either side of a bollard. The following are some principles that should be considered during the design of an HVM scheme. Keep security measures proportional to the risk, appropriate to the situation, and affordable. Make the scheme adaptable, so that changes can be made if operational needs change, or if threats change. Consider aesthetics, and additional functionality of the HVM measures. Consider who has to live with the measures, who has authorized access, and how the impact on pedestrians can be minimized. Ensure measures can be maintained, so that they continue to operate for a long time. Hostile vehicle mitigation measures can be any single, or a combination of measures. Hard landscaping designed early on in a development is one of the most cost-effective methods, and if done well, one of the most aesthetically pleasing. Best practice guidance says that a landscape measure such as a bank or hardscape feature should rise at least 1,200 mm from the road level, and at an angle that is greater than 50 degrees from horizontal.
Here in the text is a diagram of a pickup truck against a 50-degree slope, with a family safely walking on the raised platform. The next image is a real-world example of landscape HVM measures that were designed at concept stage. It would be very difficult to build this type of security onto something after it had been constructed. You can't quite see in the image, but the road is on the right, and running parallel to the facility that is on the left, behind the palm trees. On the far right of the image is a row of 500 mm tall planters, that are big enough to support trees. As such, they will offer a good degree of hostile vehicle mitigation. However, the strength of these defenses are in the middle of the image. A water feature with a 60-degree angle, raising about 1.6 meters from the road surface. It is further enhanced by the 1-meter trench that holds water. The planting improves the aesthetics further, and attracts wildlife, to make it a very pleasant and safe public space.
If it is not possible to alter the landscape, then hardscape features can be added. They will act as HVM measures providing that they have sufficient dimensions and mass to stop a vehicle. The general guidance is for at least 500 mm high, and if there is a pedestrian route between the measures, then a clear gap of 1,200 mm is required.
At this point, there is a diagram of two people walking between bollards that have been set to 1,200 mm apart. The following images are some real-world examples of hardscape HVM measures. You can see the use of planters, seating and retractable bollards, to allow authorized vehicles to enter the secure area. This location also clearly shows a standoff space between the road on the left of the images, and the facility, which is on the right.
The maximum gap between HVM measures is 1,200 mm, as measured at 600 mm from the ground. Any bigger than this and a small vehicle could encroach on the secure area, or a larger vehicle with enough momentum could penetrate the HVM line sufficiently to cause significant damage to the target. This gap refers to the measurement between an individual HVM measure and the next, rather than any shroud, cladding or camouflage that may be applied. This measurement also applies to the gap between the last HVM measure and a structure, such as a building. Various studies have shown that a gap of 1,200 mm between obstacles will have only slight impact of pedestrian traffic, including people with wheelchairs and pushchairs.
There is another diagram at this point in the text. It shows 3 bollards, evenly spaced away from a vertical structure. The gap between each is 1,200 mm. The diagram shows that the gap measurement is taken at a height above ground of 600 mm. In the diagram, each bollard extends below the ground into a substantial foundation. The final dimension on the example shown is that the minimum height for a fixed HVM measure is 500 mm. Many measures are greater than this, because an HVM measure that is around 900 mm gives a far better performance than one of 500 mm.
A point to note is that the foundation of an HVM measure is equally as important as the structure above the ground. It can be thought of like an iceberg, in that most of the strength is under the surface. Whatever is above the ground usually dissipates the energy of the vehicle on impact through the ground. Normally you cannot see what is below the ground, but the following photograph was taken during an HVM installation.
The example in the photograph showing the HVM foundation is a scheme that was devised to resist an angled impact as it runs parallel to a road. The protected area is on the left of the image. This is why the smaller base can be used to avoid existing obstacles, such as trees and manhole covers. The larger base was used wherever possible, and all of the measures were bolted together before they were cast in concrete. That completes this section of audio. We try to keep narration short, because there is a lot of information contained in this section. If you want to, you can listen again, or read the section and switch between text and audio. When you are ready, you can proceed to the next section or subsection within the module.